student friends and physics loving people, welcoming you to another video on wave particle duality. This video will show you how the wave can be treated as particle as well as the particle can be treated as wave, and this dual nature of particle or wave is known as wave particle duality. So let's proceed to understand what actually it means. While discussing this wave particle duality, the first thing that we know is that regarding radiation, that the radiations are something like wave, as they exhibit some of the phenomena like interference, diffraction, polarization, etc. And on the other hand, the photoelectric and Compton effect, which involve energy and momentum transfer, confirm the particle aspect of radiation. So as we have shown in the last video, that photoelectric and Compton effect clearly indicates that the radiations are just like particles, and in the sense that radiation which have both wave and particle nature are surely to have wave particle duality. Now natural question comes into our mind: if your radiation has this kind of nature, there's both wave and particle, then why not the particles like electron, proton, etc. exhibit the wave-like character? It was Louis de Broglie in 1924 showed that the moving particles or the matter can also exhibit wave-like character under suitable conditions, and he put some justification for his in support of his words. The justifications are like this: natural law of symmetry. This means that it manifests both as matter and radiation. So if the radiation shows dual nature, then definitely matter also shows it. And then came the close parallelism between mechanics and optics. In mechanics, we have a least action principle, which is nothing but analogous to the Fermi principle in optics. In least action principle, we see that a particle follows the path where the action is minimum, and in the Fermi principle, we see the light choose the path where the time is minimum. So this close parallelism between mechanics and wave optics definitely shows that that matter can also exhibit dual nature. Mechanics is related to particle and optics is related to wave. The number 3, Bohr's theory of atomic structure. The Bohr theory of atomic structure states that momentum is integral multiple of this h by twice power h cos, or energy is some difference of two integers. So just like in waves, or taking case of interference of mode of vibration of strings, we see some integer rules there also. So since integer rules are there in wave also, and as well as in atomic structure also, so this definitely led us to think that matter will also behaving like wave also. And it was de Broglie who put the concept of matter waves, which simply says that a matter can behave like a wave, and thus matter can show both wave particle duality. And he proposed the relation which led to Nobel Prize in later course of time. There's lambda equal to h by p, where lambda represents wavelength and h is Planck constant and p the momentum of the particle. So the particle nature is related with p, and lambda is showing its wave nature. So since wave is connected with momentum, that is particle nature, so this relation clearly indicates that there is a relation between wave and particle. So, and this particular relation that establishes the fact that matter also behaves like wave, and thus proves the dual nature of matter. And then surely a question comes: what type of wave is this matter wave? And if you take into account our concept on waves, just like sound wave or electromagnetic wave, we see that there is some periodic variation of some quantity there. And for example, in the sound wave, it's a variation of pressure. In electromagnetic wave, it is a variation of electric and magnetic fields. There are periodic variations make us these waves. So definitely the natural question is there: what varies in a matter wave? So there must be some periodic variation of some quantity which comprise this matter wave. And this is something abstract kind of thing, and to understand this we talk about a quantity that is wave function, and its symbol is psi, and we said that the variation of psi makes the matter wave. And just like sound wave, where the variation of pressure makes the sound wave, here we say that variation of wave function makes the matter wave. Now, important thing is that what is this wave function? Does it have some physical significance? The answer is no. It does not have physical significance, and it's a complex quantity. But if you take the modular square of this quantity, we designate that modular square of this quantity, that is psi modular square, as probability density, and thus we can find the significance of this psi. And directly now that we can say that matter wave is a wave of probability, and that variation of psi, that is whose absolute square gives the probability density, makes up this particular wave. And the physical interpretation of wave function was put forward by Max Born, who said that molar square of psi square is the probability density, that is probability of finding a particle within an unit volume. Important thing that there's always difference between an event and the probability of its happening. For example, if an event means something certainly happening in space and it's a definite time, and we can detect that particle, but before we detect that particle, there is always chance that at a particular point there is maybe chance of 50% detection or maybe 25% detection, and this detection probability is related with this matter wave. So while detecting a particle, we find a particle after the detection, and before detection we say that its position is probable here, there, with some certain percentage, and this kind of variation in probability is the matter wave. So with this we can conclude that just like radiation behaving like both wave and particle nature, showing particle nature, so also particles can show both particle as well as wave nature, and thus radiation have both wave particle duality, and on the same track the matter can also show wave particle duality. And this concludes that wave particle duality is a concept which is valid for both radiation as well as particles. So with this I'm ending up this video. Hope that this video is useful for you. Let's watch our videos, keep commenting. Thank you very much once.